Well, hello everyone. Today is Wednesday, December 13th, 2017. I'm Fran Duvall, your host for the show, and I'm happy to be here in the studio with Richard Schmidt, the resident who, now, did you work for NASA, Richard?
No, I did not.
Oh, you didn't, but it's an interest.
That's it.
And Richard is here to talk to us about the NASA mission to Saturn, which actually it sort of ended recently, right?
September.
A couple months ago.
Yep.
Okay, well, let's hear about it.
Yeah, this thing took off and covered about 38 years.
Wow.
They were just thinking about it for the first 10 years or so, and then it got approved. And then it was 8 years to build the thing and get it ready to go. Then they shot it off, and it took 7 years to get to Saturn. And after you got there, it was only scheduled to go for 4 years. Well, it was pretty successful. And so they got an extension, got another 2 years to go. Then they got another 7 years to go. And so the whole thing spent 20 years up there from the time they launched to the time they crashed into Saturn. Mm-hmm. The reason they crashed in was that they were afraid, you know, maybe this spacecraft, if we just left it alone, would crash into one of the other moons. Mm-hmm. Mm-hmm. And then you'd have bacteria from Earth maybe got into those planets and or moons. You don't really want to disturb the environment there. So I says, why don't we just crash right into Saturn? As we're going in, we'll take some data. So that's what they did. They had it dive right into the atmosphere of Saturn like an asteroid.
Well, now, when you say crash into, it didn't actually hit the planet, did it? Didn't it burn up?
It probably burned up before it ever got to the core of the planet.
Okay, okay.
The planet itself, Saturn is a gas planet. Okay. So it has a rocky core, but lots of gas above it. And that gas would be thick enough to burn up the aircraft, because the aircraft was going fast. Mm-hmm. And so you know, that was the end of it. And that was the 15th of September this year.
After, I forget how many years you said.
Well, it was 38 years. It was the total thing. It started out, you know, we had Pioneer had flown by Saturn. That was one of the early spacecrafts that went out there and looking around. And when did that happen? That was 1979. And then Voyager 1 got by there, and Voyager 2 got by there. Voyager 1 went by in 1980. So that's about a year later. And another, not quite a year later, but it's still in 1981, the next year, Voyager 2 passed by Saturn. So we had 3 going by, and they got some good pictures. Mm-hmm. I looked at one of the pictures from one of those and compared it to what Cassini got, and couldn't tell the difference.
And surely the technology changed between the two.
Yeah. I mean, between the time they got there was 25 years. And so over the 25 years, yeah, there was improvement in technology. Mm-hmm. But just on a quick look at a picture, I didn't see much difference. Mm-hmm. So they got really good stuff way back in 1979.
How many moons are around Saturn?
Well, as of 2012, Cassini had found 62 moons.
Oh my goodness.
Isn't that something? Pretty hard to find these things. They're not that large. And so you take telescopes from Earth and it'd be hard to find these things. But with Cassini being up there, looking around, can spot them.
And Cassini is named after...
It was Giovanni Cassini. He's back in the 17th century. I got down here 1671 to 84. He found 4 moons of Saturn back then.
Wow.
And
whatever
Huygens,
equipment he had.
Well, yeah, he had primitive telescope to look. But even a few years before that, Christian Huygens, let's see, that was in 1654, he spotted Saturn and observed it and sort of got the idea that there's something strange about Saturn. It sort of had ears on it. And that turned out to be
that was the rings.
The rings,
right?
yeah. So that's why those two names became prominent in the mission of Cassini.
Okay.
Cassini was sent up there. It took, like I said, 7 years to get there, but when it got there, it had a little spacecraft on it that it released and let it drop down onto one of the moons. And as it was going down, it took data. Let's see where they were going. They had released Huygens lander. It landed in January of 2014, and it sent 2.5 hours of data as it was going down. So it picked up that. It got down there on the surface of the moon, and it lasted for about 1.2 hours. And during that time, they got a lot of data. And that was the whole idea, to successfully get something to go down onto the surface of one of the moons and pick up the data. And they were able to do it. So this was a pretty fantastic
So that
program.
was the mission.
The mission was to
begin
get
with.
up there and get as much information you can about Saturn and about its moons.
So can life be there? I
Why
mean,
not?
Plant or, not necessarily humans yet, but
Okay. What was discovered was the moon called Enceladus. Enceladus has water on it, liquid water. Well, guess what? That's one of the things that is primary to life on Earth. And so we have hopes that maybe we'll find something up there that indicates life evolved on that moon. Now there's another one, Titan is a larger moon. It's the largest moon that Saturn has is Titan. And it doesn't have water, it has methane. And they found a big methane lake up there. Did I mark down how much that was? I thought it was like about a 5-mile lake or so that they found. They just is a giant methane lake. Don't have a number for it. But you're not going to find life there like we have on Earth. It's a different biology that could survive in methane that can survive in water.
I see.
And so maybe there's life there of a very strange type, you know. We talk about aliens.
A real alien.
A real alien, yeah.
like,
very different.
like Hollywood would do.
Yeah. So that was one of the discoveries. And of course, finding 62 moons was a big discovery. And then let's see if I can pronounce this right. Iapeta had landslides 50 miles wide. Tremendous landslides they found. And then they found on the moon Rhea had pockmarks all over the surface, probably because it didn't have an atmosphere to stop things coming down and hitting the surface. Like the moon. The moon has pockmarks all over it. Same thing they found on Rhea. So they found things like that. Any other good things? Now that was the main items that they had found. They did many orbits. They orbited Saturn 76 times in that first 4-year period. When they extended it for another 2 years, they did another 64 orbits. Then they added on the final 7 years, 165 orbits. And then when it came time, they decided, oh, let's crash into Saturn. They altered the orbit of the spacecraft to dive up and down and get through the rings into the space between the rings and the planet's atmosphere. They didn't want to get into that atmosphere or slow it down, okay?
Right.
So they get into that area there, but they didn't know what they'd hit. You know, maybe there's some debris in there. Hey, take a chance, you know? So they did it. They went around Titan to get some of the gravity of Titan to alter that orbit so it could dive down. It dove down 22 times between April and September. So that last year, they were doing these dives up and down, getting more information about what goes on in that strange land between the rings and Saturn itself, which they didn't know about. They can now pick up more data. So to the scientists, man, it was exciting.
Oh, sure.
They were doing a lot of good stuff. What else can I tell you about? You know, when you try and put these things up into space, if you send it up slow, it's going to take a long time to get there. And these are big distances, trying to get out to Saturn. And as of the time that they sent this up, this was the largest spacecraft they had built. This was NASA. NASA was working with the European Space Agency. The two of them worked together. They funded it together. But they had built this thing bigger than any they had before. And so that was a job.
Where did it go from? Did it go from the U.S.?
Where did they launch from? I don't know if I marked that down.
I don't know if it's
I'm pretty sure it was from Florida.
Oh, it was from Florida.
Yeah, I'm pretty sure they shot it up from Florida. And in order to put this large spacecraft up, you have to have a lot of fuel. You got a lot of fuel, that's a lot of weight. So you got the weight of the spacecraft, the weight of the fuel. You better have a big rocket. Well, that's big weight too. The more weight you put in, the slower this thing's going to go. So you put more fuel in to get it to go faster. Well, now you need a bigger rocket, and the weight
It's
goes
endless.
up. Hey, what are you going to do? You know. So it's a big fight. A way around that is to use gravity. Use gravity to propel you. Now you don't have to put more weight into it. Just be clever, okay? So what they did is they dove around Venus and used the gravity of Venus to speed up the aircraft. And they went around Venus twice. And then they came around Earth and used Earth to boost it some more with the gravity of Earth. And then when it ran around Jupiter, they got another boost.
I'll be darned.
And so that way, we got there a lot faster. They got there in 7 years. 7 years, that's a long time.
That's a long time.
But can you imagine if they didn't do that, how many years it would have taken? I didn't bring that number with me, but it certainly was a lot longer. I believe it was more than triple. In other words, you'd be out there more than 21 years trying to get to Saturn. It's that far away. But by using the gravity, what they call a gravity boost, you could speed up the spacecraft and get it there faster. So that's what they did. Another problem is if you do take longer, how about the energy? You need some energy to keep all the electronics going. And you have to keep things warm, so you have to have energy to keep it warm. Where are you going to get all this energy from? Well, bigger batteries or something, right? That's more weight. Oh my gosh. You know, everything has got a penalty. You have to trade that all off. And so what they did, having this thing get there in 7 years, be able to work longer with the energy that they had.
I see.
And the guy who was figuring out, was the energy going to last until this thing dove into Saturn, he was biting his nails. I mean, he was down to the point where he said, we're running out of stuff. You know, we're not going to have it. But they did. They had calculated that it would have enough, but not by much. So it dove into there, destroyed itself, and still was sending back data as it's going into the atmosphere. And I don't know how many minutes they got out of it, but they got a few minutes of data going into the atmosphere.
Wow.
Yeah.
How exciting to be sitting in the room with, those people watching their panels or whatever they're looking at.
When you see everything going right, man, that is thrilling. Particularly, you've been working on it for so many years. Can you imagine your career being 38 years long, you know, that kind of thing? Well, at the first 10 years, they're just thinking about it, okay? The next 7 years, you're actually building it. And then you got 20 years of using it. Well, the people during that 20 years, a lot of them are new. They came aboard. But still, if they're on there for the full 20 years, that's a good portion of your career.
Yes, it is. Yeah.
So a lot of dedication there and a lot of work that came out well.
And while you've been speaking, I think that Diane has shown some images, and I don't know whether they were ones that necessarily related to each of these things.
Well, maybe she's got something there on I'll say that word again. Enceladus. Enceladus is the one that had the water. We had some images showing the water spouting up from the surface, and maybe some of those images could come up. And I had a cross-section of Enceladus that they think is what it looks like inside, that there's some heat inside of Enceladus. Where'd the heat come from? From this strong gravity of Saturn. As the moon goes around, if it's not a circular orbit, if it's got an elongated orbit, it'll have less gravity when it's far away and more gravity when it comes in. And that can compress and release. Well, you start doing that, you start generating heat. And so they think there's a lot of heat inside of Enceladus, and it heats up any water that comes down through a crack. So they think there's plenty of water. And here's a cross-section that shows you right now that interior, that orangey area is the heat. And then if there's cracks in that lake, the blue part is the lake of water, and the white on the outside is ice, because it's so cold out there. Everything is frozen, but underneath it can be liquid. Liquid because the heat in the inside. And there's some cracks that allow some of the water to get towards that heat. It can boil it and send up steam, pressure, and if there's a crack in the ice in the surface, it can squirt out as the geysers that they saw. So Cassini saw these geysers coming up, and that gave us this idea that there's a lake of water underneath.
And I suppose with you saying there's ice on the outside of that moon, that I guess they can't depend on any solar energy or much of it to warm it, I suppose.
Well, life needs some energy. And so if there's going to be life there, where is it going to get the energy if the sunlight can't get through the ice? Okay? Also, you're so far away, it's very cold. You're not getting a lot of sunlight. Sunlight is dim by the time you get out there. And that's why it is cold. So this water is being kept warm by the heat inside, and that's the energy source. That interior heat is energy.
If the gravity is fluctuating.
Yeah, the gravity is changing, causing that heat. The heat warms up the water and allows life to begin if there's a chance for life. So they'd like to get down there and take a little sample to see if there is some life down there.
So are they going to do that? Are they working on that?
They're certainly thinking about it. I don't know it's been approved. As of the time that Cassini dove in, it was not approved. Okay, these were things that people were talking about, and as far as I know, it has not been approved. You know, within a few years, maybe something can get into the budget on it. I think there is something coming, but I'm not sure if this is one of them that's going to be in it. Okay, they have a couple of them on the board.
A few projects, huh?
Yeah, that have been proposed and getting very close to being approved, if not already approved. I'd have to go check that out. You can go to the NASA site, nasa.com, and find these things out. So if you got curiosity about what's going on in space, there's where you go.
And is that where you got your images from? Was that site?
Oh, I scan all over the place.
Oh, you did? Okay.
Where I can find something. I got some of the images from Wikipedia. You know, if you don't have an encyclopedia anymore, go to Wikipedia. That's a good one.
It is.
And then just going to Google and Googling Cassini brought up all kinds of references from different places. You can do the same thing for the Huygens lander.
Now that's the British one, right? That was the British component?
Did the British make that one? I don't know. They might have.
I don't know either. I thought I saw that somewhere in
very possible.
The things I was reading.
Yeah, they may have done that part.
Yeah.
I know they funded it with the United States. The NASA budget had it, and the ESA had the budget into it.
I was just going to ask you, what do they call their space program?
ESA.
ESA.
European Space Agency.
Okay.
And so they might very well have done the Huygens part.
And if it's European, that means it's a collection of many countries.
Yeah, the European Union is what's represented by the European Space Agency.
Okay.
You know, I'm pretty sure it's not a British thing.
Okay.
It's a European thing.
Okay, it's European.
If it was British, I'm pretty sure they'd say, this is the British
Well, you're right,
Space
and I
Agency.
probably shouldn't have used that phrase.
Yeah.
Yeah, that's probably right.
Have we covered all the interesting things? I think so, unless you have some more questions.
Well, we have plenty of time, so if you wanted to talk about, you know, you've been doing this for a while, these shows, and with Andrew, and unfortunately and sorrowfully, we've lost Andrew.
Well, he had a lot of interest in this.
But he had his own interest in it,
exactly.
didn't he?
So he'd buzz me all the time.
Did he? Okay.
Yeah.
Okay. Well, maybe you can still count on him from out in San Diego. But you do you prepare? You have like a yearly calendar of what you're going to do, or
Yeah.
you do.
The next meeting that the cosmology group will have will be in January.
All right.
It's always the second Wednesday of the month, and it's every other month, starting with January. So all the odd-numbered months,
All right.
we do have a meeting. I take a vacation in July, however. July is the 7th month. We skip that one. We used to have it in July too, but
Yeah.
I
And
like to
they're
have some
being
time
held
off.
at what location here on the campus?
It's in Town Center, up on the what they call the first floor, which is
Sure.
above the terrace. It's near the Fireside Cafeteria. It's in the music room. So we have the music room on the second Wednesday of the odd-numbered months of the year, except for the July. And it was all started with Al Weinstein.
Yes, I remember.
Yeah, he started that, I would say, back in 2002.
I did a show with him, one of his first shows.
Oh, very
I
good.
hosted him. Gosh, he was a fascinating man, wasn't
Yeah, very good.
he knew so much.
What I'm doing now is using his notes. He kept notes as he went along. I kept copies of his handouts. And with those, I just follow right along. Each one he's got, we'll do that one the next month. Unless there's something new comes up.
Sure.
Like when we had, what was it? The Mars landing. Now, he didn't cover that. It didn't happen in his time.
Yeah.
So we had a special meeting just on the Mars landing. Then we had the one where I think it was the Europeans sent out a spacecraft that went way out past Jupiter and around and caught up with a comet. And they actually landed on the comet. Just like the Huygens dropped down onto here. They had a little lander land down. It fell over, unfortunately. And so they got some data, but not too much data out of the thing. It fell into a crevice, and the shadow cast over it.
Oh.
Well, the shadow took away the energy because they were using solar energy in order to keep that thing going.
Yeah.
And
So
when it got closer to the sun, then they got some energy back, and they got some data back out of the thing. So it woke up after many months of sleeping.
I read in the paper just last week or something, and I don't know which project it was, but they had you pretty much used up their thrusters or something, this particular craft. And so they couldn't regulate, I think, direction. So then these brilliant minds down in NASA come up with, well, let's try to use these other thrusters that are actually used for some other purpose to see if we can do that. And apparently they were able to make use of it.
That's what you do. If things don't go the way you planned it, but you have other things that are on there and you think, oh, gee, if I try this, this is what it would do. It's in the right direction. Let's see if we can goose it a little bit. Okay, let's try it.
It's amazing the communication that can go on. Now, the communication from Earth to one of these spaceships, I'm calling them, how long, I mean, is that lengthy as well? I mean,
Well,
it doesn't
takes
take maybe 7 years, but...
It takes 8 minutes
Really?
for the sunlight to come from the sun to the Earth.
All right.
And so it's traveling at the speed of light, and that's what communications will do,
Okay.
is speed of light.
All right.
And so now when we went out to Mars, I think it was about 14 minutes or so to go from Earth
I
to
see.
Mars.
Okay.
Well, Jupiter's out past the asteroid belt. You go from Mars, asteroid belt, Jupiter. You're getting way out there. It's getting pretty long to get there. And now you got Saturn further out than Jupiter. It takes a while.
Okay.
I don't have a number on that.
But
as
still,
to
they
what the
can
time.
communicate. I mean, it's a
You can
reasonable
communicate.
length of time considering
Yeah.
where they are.
When we were talking to our spacecraft that went out to Pluto, I'm trying to remember. No, I guess I can't. I was going to say it was 3 hours or something like that, but I
see.
don't know. But it's not a day,
Okay,
you know, it's
okay.
a period of time to get the signal out there. And if you tell it to change course, because you're really sure that if you're going the way you're going, you're not going to hit the target right. You got to move a little bit. Well, by the time it gets there, some time has elapsed. And that's what was happening with Pluto. We had to go out there and tell them hours ahead of time, you know, do this and hope the best. It's going to get there at right time, do everything. And it did. It did it very close. The Pluto shots were excellent. They took a lot of good pictures of Pluto as it passed by. It was just a flyby. They didn't orbit Pluto.
Yeah.
They took that out. They took a look at there, took some pictures, and flew past it. It's now continuing out into space, looking through the Kuiper Belt. The Kuiper Belt is where you find other large rocks and pebbles and dwarf planets such as Pluto. Pluto is the inner edge of the Kuiper Belt. And they found other rocks out there that are bigger than Pluto. So poor Pluto, he got demoted.
Yeah, he did.
He's not a planet anymore. He's a dwarf planet. And they got two others out there that are, one is a little smaller than him, I think, and one is bigger than him. But there's more out there, and now they're saying other things are going on with orbits being disturbed. What's causing the orbit to be disturbed? Oh, there must be other guys out there. And so I think there's two others now that are suspected. And they're saying one is a really big one, and it's causing a deviation of some orbits. And then they found this other one, I think it's supposed to be Earth-sized. Well, that's a heck of a lot bigger than Pluto. Okay, and so they haven't found it yet, but they're saying the data seems to say there's something out there about the size of Earth. You know?
Wow.
So all these things are going on. And of course, we got all the data on planets going around stars now. You go out there and you look at these stars, they got planets around them.
Wow.
And it's very common to have planets around. It's not, oh, geez, this one has a planet and maybe that star has. No, every star has planets, or almost every star has planets. What a difference. And when Al was given the talks, they didn't have this data on these exoplanets, the ones around stars. When we gave the talk on Kuiper, the Kuiper telescope, it had come up with thousands of these planets, way beyond whatever Al had at the time. Yeah, lots of progress.
I don't know, maybe if you believe in this sort of thing, maybe he's out there taking care of some things.
Right.
Listen, thank you very much.
You're quite welcome.
Richard. It was very exciting hearing all of this.